Okay, some people had some questions on one of the My Math Lab problems, so I thought I'd just make a video. Again, start somewhere, so don't give up, just try something. And so a lot of students who struggle with the problem, at least they had a great idea of taking that 0.56 and dividing it by 10 years to get that it's about 0.56, so 56 hundredths of an increase in age. So this would be increase in years of age over one calendar year, right, instead of for a decade, okay? And so then after you deal with that, try to think about other similar problems that you know and kind of how they work, like the Thanksgiving problem or even adding tip to a meal, things like that. So our starting age here is 72. And we know that according to this model that it's going to increase over time. All right, maybe due to scientific advances, vaccines, different things, whatever. And that increase is going to be 0.56, and that's a rate, so it has to be multiplied by something, and that would be the number of years that take place. So if only 1 year takes place, and it's the year 2016, that would be 72.56. If 10 years went by, a decade, then we would add 5.6 to that and get the result. But our goal is to figure out when is that going to hit 150. So what we can do is we can subtract, okay, if we use a little bit of algebra here, and figure out how many years is elapsing from the time someone is 72 years old to when they become 150. And so if I subtract, I get 78. So that's a time, an increase in 78 years, and I know the rate. So again, to work backwards, I would undo the math. So if I knew forward, I'd take the years times the rate and add. But to go backwards, I'm going to subtract and divide. I'm going to do inverses to undo the math. Right, and so the number of years, so I'm going to take my 78 divided by 0.56. Right, and that's going to be approximately about 139 calendar years. Okay. All right, so if I wanted to add that to the year 2015, that would be about in the year, let's see, about, okay. All right, so in that calendar year. All right, so again, you don't have to do algebra in this course, but again, algebra is a great problem-solving tool. Right, the main thing is to get this per year. And then the next thing is to figure out how many years are going by or elapsing between the 72-year-old person and a 150-year-old person. And then again, if going forward you would multiply by that rate, when you undo it, you would divide. So some people might not do any algebra on this. They might just kind of orange scratch paper take, well, I'm going to subtract to figure out the years and get the 78, and then they might be like, well, if I went forward, I'd multiply by that rate, so since I'm going backwards, I'm going to divide by that rate, and they'd still get the same answer. Hope that helps. If you still have more questions, let me know.